When working with exponential expressions, we want to make sure that we know what the exponential expression is portraying to us, and also how to simplify exponential expressions that are involved in some operations. So let's first review our information about exponents and exponential expressions, and then we'll look at some rules of exponents that will help us simplify expressions. Now recall that exponents represent repeated multiplication. So when I have an expression like 5 to the second power, that means 5 is multiplied to itself, two factors. So we have 5 times 5. 5 is multiplied to itself, and I have two of those factors of 5 multiplied together, and I get 25. If I have 3 to the fourth power, that'll be 3 times 3 times 3 times 3. And when we multiply these, we multiply as they occur from left to right. So 3 times 3 is 9, times 3 is 27, times 3 is 81. Now, exponents are only powerful enough to reach what's in front of them unless they have help from parentheses. So if I have an expression that shows me an open parentheses, -4, close the parentheses to the second power, then the second power is right on the close of the parentheses, so it's acting on the entire expression that's within that parenthesis grouping. So that means -4 times -4, which gives me a positive 16. However, if I just had the opposite of 4 squared, so that there's no parentheses in the original problem that I've been asked to simplify, then the exponent of 2 is only on the base of 4. And in our order of our operations, our PEMDAS, we want to do what's inside parentheses first, which we don't have parentheses here, then our exponents. So here I need to square the 4. 4 squared is 16. And then by the time I get down to after the multiplication division as they occur from left to right, and then our adding and subtracting as they occur from left to right, our 4 squared is 16, and then we apply the minus sign afterwards, so that is the opposite of 16, or -16. So be very, very careful about whether there's parentheses in your original expression or not to what you need to do. And if there are parentheses in your original expression that is grabbing a negative number to a power, you need to key it into your calculator this way so that you get the right value if it's an expression that you're evaluating with your calculator. Now, vocabulary-wise, in exponential expressions, what the exponent is acting on is the base of the expression. And the power that tells us how many of those bases were to multiply together is your exponent. So if I have an expression like -7 to the third power, and it just wants me to identify the base and the exponent, and it doesn't say to actually simplify it, but just identify the base and the exponent, then here my exponent of 3 is right on a closed parenthesis. So the base is the entire thing that exponent is acting on, -7. And the exponent tells me how many of those factors, so it's 3. In the previous example, our opposite of 4 squared, in this one our base would be 4 and our exponent would be 2. Just identifying the base and the exponent. Okay, so once we have that information down, we want to look at what we would do in terms of simplifying some exponential expressions. Now here to the side we have the rules of exponents. Rules of exponents give us an indication of what to do when we're simplifying our exponential expressions involved in certain operations. The first rule of exponents says that when we're multiplying exponential expressions that have the same base, notice here the base is x in both of those cases, then to simplify that expression, we keep the base and we add the exponents. When we have an exponential expression to yet another power, we keep the base and we multiply the exponents. When we have an exponent acting on a parenthesis grouping that holds a multiplication inside the parentheses, and they're not the same base inside the parentheses, then to simplify that expression, they each get the exponent. If I have a quotient that's grabbed in parentheses to an overall power, each the numerator and the denominator gets the exponent. If I have a quotient of exponential expressions that have the same base, we're going to keep the base and subtract the exponents.